3.8, solving system equations using inverse matrices. So this is a big lesson. I'm going to show you how to solve system equations using matrices, which makes it a lot faster than doing by hand or using Cramer's rule. So first, to do that, we have to talk about identity matrix. Now, if you remember what identity means from mathematics, it's where you multiply. It's a number where, in multiplication, where you multiply by it, and you get the same number back. So in regular multiplication, it's 1. In addition, right, you want to add to something and get the same number back, it's 0. So in matrices, when we're talking about identity matrix, we're talking about a multiplication. So when you multiply it, you multiply a matrix by it, and you're going to get the same matrix back. And that's kind of hard, because remember, matrices are like this row by column thing. Right? You can only multiply certain matrices together. So what's an identity matrix? It's this thing. 1, 0, 0, 1. That's an identity matrix. If you multiply by that matrix, you're going to get the exact same thing back. And then same thing for 3 by 3. Or in general, n by n. If you want to do an identity matrix, all you do is do 1 like as your diagonals, and everything else 0. So if I was going to do a 4 by 4, it would look kind of like this. Just have that one diagonal of zeros, and everything else of 1, everything else is 0. So that's an identity matrix. You multiply by that thing, and you get the exact same thing back. So let me show you. Let's do an example. So let's do 2, 3, negative 1, 4. Now we're going to multiply this by the 1, 0, our identity matrix, 1, 0, 0, 1. So remember the way we multiply, we'll put it up here. We'll draw a line so where there's a space. And then what we do is you multiply the first 2, so 2 times 1 is 2, plus multiply the second 2, 0. So then I get to this one, right? So I want to multiply this one, row 1 by column 1, multiply the first 2, 0, and add the second 2, negative 1. Remember, it's all about rows by columns. Rows is the first, columns is the second. So then we have row 2, we're going to multiply by the first one, so 3 plus 0. And this last one here, this row by that column is 0 plus 4. If you look at it, we get 2, negative 1, 3, 4. Right, we get the exact same thing about the identity matrix. Now I can actually flip it. We can do it the other way, right? Because remember, multiplying matrices is not cumulative. So you can actually flip into the exact same thing. Right here you get 2, right here you get negative 1, here you get 3, and right here you get 4. Right, so it doesn't matter. In either way, that's what this says right there. If you multiply a matrix by what we call the identity matrix, you get the same thing back. And it works the opposite way also. So that's an identity, right? You multiply it, you get the exact same back. In the matrices, that's 1, 0, 0, 1. Now, after we do identities, next thing we do is inverses. Remember, inverse is how we solve things, right? If we have 3x equals 9, the way you solve this, you don't divide by 3. What you're actually doing is you multiply by that inverse. You multiply by 3 by its inverse, which is 1/3 in multiplication. These cancel out because they're the identity, and you just get your answer. Multiplication identity is 1, so that's why you get that. That's what inverse does. An inverse of something cancels it out, so you get the identity. So inverses cancel each other out, and you get the identity back. So how do we tell if two things are inverse of each other? Well, when I multiply these two things, right? If these two things are inverse of each other, then when I multiply them, I should get the identity back, which is that 1, 0, 0, 1 thing. So it's a quick way to tell if two matrices are inverse of each other. Just multiply them and see if you get that one, if they cancel each other out. And by cancel each other out, we mean we get that identity. So multiply this together. You're supposed to try both ways, but honestly, if it works one way, it's going to work the other way. So again, multiply the first 2, I get 1, plus multiply the second 2, I get 0. Over here, multiply the first 2, I get 1, plus multiply the second 2, negative 1. Down here, multiply the first 2, 0, plus the second 2, 0. Right there, multiply the first 2, 0, plus the second 2, 1. And if you add this up, I get 1, those cancel, I get 0, 0, 1. So yeah, these are inverses. Right, they cancel each other out when I multiply them. They're inverses. Let's try this one real quick. You probably could guess this is not going to work. So 2, 5, 1, -3. I multiply the first two, I get 4. And then I multiply the second two, I get 5. You add them up, I get 9. So right there, I can stop. I got 9. 9's on my, so they're not inverses, so not inverses. I don't got to go any further. I got 9 on the first one, so definitely not 1, 0, 0, 1. So that's a quick, easy way to tell if two things are inverse to each other. So when you multiply them, they should cancel out. You get that identity back. So now we know what identity is in matrices. 1, 0, 0, 1, right there. We know how to tell if two things are inverse to each other, if they cancel each other out. The next thing is, how do I find an inverse by itself? If I just want an inverse of a matrix, how do I find it? Well, with that, we have a formula for it. And it's right here. And actually, I'm going to rewrite the formula. So the general idea is, if I give you A, which is this, let's say A, B, C, D. And if I want the inverse, A to the -1 power, what we do is 1 over the determinant of A, which is that right there, but we call that the determinant of A. That's the same thing. Then right here, it's a little funky. What you do is you switch these two, and then you change the sign on these two. So if they're negative, they become positive. If they're positive, they become negative. And that's the formula. Again, I will provide you the formula. I always provide you the formula. So you just gotta know how to use the formula. So you have that. So let's go here. Let's do this example. Let's find the inverse of this thing. So first thing I like to do, you don't have to write it down, but in your head you want to know what A, B, and C, D is, right? So step 1, if we want to find the inverse, it's 1 over determinant. So remember the way we do determinant? We go down minus up. So 6 times 0 minus -3 times -1. You get 0 minus 3, or just -3. So again, just do determinant first. So down minus up. Next part. Alright, so now I gotta put this part here. So we're gonna switch these two, so that becomes a 0 and that becomes a 6. And then we change the signs on these two. So that -3 becomes a +3, that -1 becomes a +1. And that's my inverse. But we're not done there. You gotta distribute that thing. And we're multiplied by that scalar. Which is a fancy way to say a number in matrices. So 0, -1/3 times 3 is -1. -1/3 times 1 is -1/3. And -1/3 times 6 is -2. So there is my inverse. Now if you want to check and see if, let's check and see if it actually works, right? If they're inverses of each other, when I multiply them, I should get the identity, -1, 0, 0, -1. So I'm going to do a quick check, just to show you, just to prove to you that they are. Alright, draw a line here. Multiply the first two, I get 0, plus -3 times -1/3 is just 1. Multiply those, I get -6. -3 times -2 is +6. Here I get 0 plus 0. Then here I get 1 plus 0. So look what I get. 1, 0, 0, 1. Right, so they are inverses. So this method does work. Right, so that's the way you find inverses. Let's do another one. Let's do this one real quick, actually. We'll do these two, and I'll try to make them quick. So right here, right, so I'm going to do the formula, which is 1 over the determinant of A, inverse. And then the formula here is switch these two and negate these two. Okay, so let's do this, right? So it's A, B, C, D. So first the inverse, the determinant I should say, down minus up, I get 1 over 12, because 2 times 0 minus 4 times 3. Oh, 1 over -12, sorry. Then right here, I'm going to switch these two, so 0, 2. And I'm going to change the sign on those two, so that's 4 and 3. Let's distribute. And I get 0. 4 times 12 is 4 over 12, which is -1/3. 3 times that to be -1/4. And 2 over 12 is 1/6, so -1/6. So, one reason I did that is I want to show you doing the calculator. So it's actually very easy to do. So bring up your calculator, turn it on. And we're going to go to second calculator, I always do that. We're going to type in our 2x2 matrix, the starting one. So let's make it 2x2 this time. 2, -4, -3, and 0. And all we're gonna do is this. So we're gonna select our matrix, the one we just did. Now we want to hit the inverse button. Inverse. Well, that's actually the same button as the matrix button, just without the second. That one right there. Hit enter, and there's our answer. There's the inverse. But I don't usually like long decimals, so what we're gonna do is make that a fraction. Very simple. Just go to math. And see how the first one says arrow fraction? What that does is it makes sure it enters into a fraction if it can't be turned into a fraction. And there we go. 0, -1/4, 1/3, -1/6. Same thing I got right there. So that's how you do the inverse with your calculator. One more of these inverse ones, and then we'll talk about what everybody really wants to find out is how to solve this with how to solve equations with your calculator. So real quickly, the formula is 1/determinant of A times the switch -b -c. Anyway, determinant here, let's do it. Down minus up. I get 4 minus 4, which I get 0. So if I plug it in, I get 1/0 times all this stuff. 1/0? You can't divide by 0. So this thing has no inverse. I brought this up in the last video. Remember, if the determinant equals 0, then you have no inverse. Because that's the whole reason why. Because the very first step of finding the inverse is dividing by the determinant. So if the determinant is 0, you can't divide by 0. So just keep that in mind. Determinant of A equals 0, there's no inverse. I will ask you about that on quiz or test. Anyway, let's go to the fun part of today. I'm going to show you how to solve equations using your calculator, the matrices. So right here's the whole step of how to do it. I'm just going to show you. You can look at that later if you want. So this is kind of the idea. We're going to write it as a... I'm actually showing you two ways to solve your calculator. Let's do the proper way first. We're going to write it as a what do we call it? Coefficient matrix. So -2, 1, 1, x and y. Kind of like we did Kramer's rule. I showed you real quickly. 9 and 3. Then here's the idea. I'll put this in my calculator as matrix A. This is pretend it's x. I'll put this in my calculator as matrix B. Now if I want to solve for x here, which is my goal, I want to cancel out A. And the way you cancel out matrices is you multiply by the inverse. So you multiply this side by A inverse. And if whatever I do on one side, I'm going to do it to the other side. So multiply this side. Now keep in mind they're both on the left side. Remember, because matrices you can't multiply AB and have it be the same thing as BA. So if I multiply on the left, multiply on the left. These will cancel out, and you just get the identity, which is essentially 1. You get an answer like this. So that's one way to solve in your calculator, is that you just rewrite like this, put this in your matrix A, put this in your matrix B, cancel out the A by doing the inverse both sides, and this is all on your calculator. Or by hand if you want to be a masochist. So let's do it real quick. So I'm going to go to my matrix, I'm going to type 2 by 2, I'll type that one in. It's -2, 1, 1, 1. Right, I just typed in my coefficient matrix right there. I'm going to go back to my matrices. And this time for B, I'm going to type in that little 2 by 1. 2 rows, 1 column. Right, and then 9 and 3. And then all I'm going to do is what I have here. Get my first matrix, I get an inverse, and then times it by the second matrix. If I do that, press enter, I get my answer of -2 and 5. So x equals -2, 5, which my answer is, remember, always use a coordinate point, -2, unless it's an application problem, -2, 5. Right, so that's how you can solve in your calculator, and it works for 2 by 2, 3 by 3, 4 by 4, it always works. So that's one way to solve it using a calculator. Let me show you an actually even easier way than this one, a faster way. And what's something that's called reduced row echelon form. If you ever take linear algebra, you know more about it, but this is the fastest way to solve a system of equations that I know. So another short for this is RREF. So in linear algebra, we learn all these row operations, how to add rows, subtract rows, all this cool stuff. Anyway, and one of the things we can do is put into reduced row echelon form. What that is this. We're going to write this as what we call an augmented matrix. Which just means you write as one big old matrix. So 4, 6, -2, 9, 22, and -3. Right, so I'm going to write as one big 2 by 3 matrix. And then in my calculator, I'm going to put RREF, and I'll try to get there right now. And what that's going to do is do all these elementary row operations for us to make it this part right here the identity. So it's going to be 1, 0, 0, 1 on this side, and then whatever's on this side is our answer. And that's going to be it. So let's show you an example real quick. We'll actually do a few of these to make sure we got this. So I'm going to go to my matrices. I'm going to type in a 2 by 3 because I'm going to put it all together. Type in everything I see. So 4, -2, 22, 6, 9, and -3. So there it goes with my matrices. I'm going to get out. Go back to my matrix. Now, before I select them, I'm going to go to math. Remember, that's the thing that does everything for us. There's a determinant, there's all this other stuff. You go toward the bottom. There's RREF, reduce row echelon form. It has to be the double R one. Select that. Now select your matrix. And look what it's going to do. There's identity, and it says the answer is 4, 3. 4, -3. That's our answer. And again, that's the easiest way I know how to find an answer using system of equations. Faster than doing it by hand, faster than doing anything. Well, 2 by 2 is actually kind of debatable. But 3 by 3, 4 by 4, that's the easiest way to do it. Reduce row echelon form. And again, we'll talk more about this in linear algebra, but for now, that's the easiest way. So let's do a couple more examples, and we'll do a 3 by 3 to finish off, and then we are done with this lesson and this chapter. So let's do an application problem first. Kevin has 25 quarters and dimes. The total value of all the coins was $4. How many quarters and dimes did Kevin have? So with problems like these, there's always going to be two equations. There's going to be a value equation and a totals equation. So let's do the total one first. He has quarters and dimes. He has 25 of them. So if he had quarters and dimes, he has 25 total. That's my total equation. Now let's do the value equation. Quarters are worth 25 cents. Dimes are worth 10 cents. So the total value we have is $4. I guess something like that. And again, solving this elimination or substitution, not the first thing in the world, but there are decimals. Easiest way to do this, calculator. Type it in, right? So I'm going to go 2 by 3. I'm going to type in 0.25, 0.14, 1125, right? All we do is a coefficient. We get out, we'll do RREF with the A again. I'm just going to go up and select it. That's the fastest way of doing it. Then you press enter, and there you go. 1001, and I think it was 10 to 15, but let me double check. Yeah, 10, 15. So this is an application problem. So then I actually got to write in the sentence. So 10. Okay, so this is the way this works. So quarters is column 1, dimes column 2. So this is quarters and dimes. And why do we know quarters is 10 and dimes 15? Or which one's which? See how quarters is column 1 and there's no value right here? So it's the only value is right there. So quarters is 10. And then for dimes, there's no value on top. Dimes is down here. So dimes is 15. So you have 10 quarters and 15 dimes. Application problem, I'm going to write our answer in the sentence. So like that. So that's how you do an application problem. That's how you solve a 2 by 2. Now for our big finish, let's solve a 3 by 3. Actually, I'm going to go back to my notes from 3.7 real quick. Right there. And let's scroll down to the bottom. We're going to do a 3 by 3 by hand. At the very end. There we go. So let's do a 3 by 3. And again, the easiest way to do this is do reduce row echelon form. RREF. So we're going to write this as a big 3 by 4 matrix. Okay, a big augmented matrix. I'm going to do RREF of all this. Now, the key thing to keep in mind is don't forget the negatives. If something's missing, you put a 0. Like if there's no Y here, you put a 0 for its placeholder. Right, because it has to be column X, column Y, and column Z. So again, if you have something missing, put a 0. Right, so all we need is put that in my calculator. All of it in there. Second matrix. Make this a big 3 by 4. So I typed it all in so you don't watch me do it. And I noticed a mistake. This should have been 3. I was thinking about the 0 thing and I wrote it in. So you type it all in, right? Now we can get out. go back to matrix, go over RREF toward the bottom, select our matrix, and get an answer. -451. So my answer is -451. -1. Knew something was a little off. And that's the idea. That's the easiest way I know how to solve a system of equations. Now from now on, since we learned it now, you can do this. If I give you on a quiz or test, you could use RREF if you want, instead of doing it by hand. Anyway, that's the lesson.